A drilling stabilizer is a piece of equipment used in the bottom hole assembly of a drill string. It mechanically stabilizes the assembly in the borehole in order to avoid unintentional sidetracking and vibrations. Drilling Tools International forged stabilizer bodies made of alloy steel 4145 are brought to the Broussard, Louisiana facility ready to start the milling process. This is where the stabilizer's story begins. The 16-inch alloy stabilizer weighs about 1,800 pounds. Inside the Broussard plant, the body of the stabilizer is machined to the specified diameter for both the outside and inside dimensions. The blades will be machined for about 14 hours while the cutter heads slice a 32nd of an inch material each pass using 3-inch cutters with 7 carbide inserts. The carbide inserts are replaced on a regular basis, which means this stabilizer will go through about 120 inserts before it's done with this step. The alloy is a much harder material than steel. In comparison, a steel stabilizer will go through only 14 carbide inserts. From here, the stabilizer is taken to the DTI furnace. Stabilizers are preheated to 850 degrees prior to applying the hard facing. The welding shop is the next stop while the stabilizer is still very hot from time in the furnace. Here, the stabilizer will have a carbide hard facing applied to the blades. The abrasive carbide helps drill formation and it prevents the stabilizer from wearing down. After the furnace and welding, the stabilizer gets a short timeout to slow cool to room temperature before being moved to the grinder. The welded hard facing on the stabilizer blades needs to be ground down to the designated diameter. When the blades are within plus or minus 5/1000ths, the blade manufacturing process is complete. Creating the connections for the stabilizer at the CNC lathe is a 2-step process. First, they blank out the connections for threading. Then the insert is threaded. The stabilizer is moved next door where the thread roots are cold rolled to strengthen connections. The roller applies force to the surface of the tapered thread. As it penetrates the metal surface, it displaces the thread material and restructures the crystalline lattice of the steel grain structure. A phosphate bath is the next stop at the DTI facility. Phosphate coating provides strong adhesion and corrosion protection and also improves the friction properties of sliding components. Stabilizers spend 1 minute in a water rinse before they're moved over to the phosphate tank. There, they're submerged into the hot phosphate solution for 8 to 12 minutes. Once the phosphate process has been completed, they go back in the water tank for another 1 minute to rinse off excess acid. After the rinse, the stabilizers are cleaned up and then go through an eraser test to make sure none of the phosphate edging has been removed. The stabilizers are now done with the manufacturing process. After final inspection, they will be painted and prepped for shipping to clients around the world.